Kalau nang sas kasar.
না এইটো নহয় এইটো
হৈ আছে এইটো হৈ আছে
হৈছেতো হৈছে এইটো এইটো হ'ব না
কিয়
পাগলা নেকি নহয় কেমেৰাটো আছে
স্ক্রিন শেয়ার অপশন না থাকে তো
Okay, so for how many participated?
mute
মিউট আছে
মিটটো এস লাইভ স্ট্রিম
দি এর পুলিশ করে ভিডিও পুলিশ করে
Mano, meet for you.
আগে হলে হ্যাঁ
Okay, let's begin for today's session. Please sit properly and try to listen me and try in your best level to understand me. And from my side also, I will try my best level in the easy manner that you can easily. It's not audible? Am I audible?
Yes sir
Okay. So the topic that we have choose for today's session is quadrature. Actually, it is the applications of integration, the integration that we discussed. For that, this is the application chapter. And actually, to solve application problem, as you know, a lot of previous knowledges we needed. हम क्लास 10 के भी हो सकता है, क्लास 11 के भी हो सकता है, और बहुत सा previous knowledge we needed to solve the application situation. So yes, please. Am I audible? Am I audible or no? Audible? Check. Okay. So let me begin with the session. Okay. Let me begin with the session by recalling some previous knowledges that will be needed to our topic. That is the quadrature. So first of all, I would like to actually define what is the quadrature and what we are going to do in the application of integrations. Is that we are going to find the area of the region bounded by a given curve or by curves using integration. So by using the integration, we are planning to find the area. In this regard, we need so many actually previous knowledges. So before directly beginning about this topic, I would like to actually have some revision that we already taught in the previous classes. That will be very actually beneficial to you in solving the application questions of integration. And then actually the guest needs to know every year CBC to us 1 5-mark any question from this area. And at present, actually the syllabus given by the CBC for this topic is already mentioned here. In this actually what we are going to find and what we have to do is to find an area under the simple curves. Under the simple curves, especially lines, circles, ellipse, parabola, and they are also given in their standard form. Because of why? First, we need to know standard equations of these curves, so that when we actually use integration, finding the area of these curves, and we have to actually we will need the actually standard equations of these curves. Sometimes it may be given a program in a line, sometimes circle, sometimes ellipse, sometimes actually parabola. We cannot actually say this particular curve should be given in the examination, because of why we need to have very quick revision or quick recalling about the actually these curves one after the other. So with this, let me actually start my session. Yes, Say here by the curve. As you know, our topic is application integration. In this, we are going to find the area of the region under the simple curves like line, circle, parabola, and ellipse. For what we have center, only these four curves are actually in the syllabus. So these curves we need to know first. So by the curve in this discussion, what the syllabus, what the according to syllabus does it mean is number one is line. Line. Actually, the line topic was discussed in the class 11, but we are needed in this topic. So you know this equation, standard equation of the line is what? Ax plus by plus c. It means in an equation, two variables are here, and both the variables x and y possess the same degree 1, 1. At the time, that equation is represented a straight line. So sometimes it may us to find us the area of region under this straight line, bounded by this straight line. Okay. So because of that, you must able to identify that the given curve is the line. So how you can identify if your equation involves two variables, that the variables, what the variables, the degree 1, 1. At the time, you should know that equation represents the line. Okay. And the second one is circle. This circle. So equation, standard equation of the circle. Say circle topic was also discussed in the class 11 about the standard equation and about the coordinates and radius. We know it in the class 11, but we need the equation of standard equation of this topic. So how you can know the given equation represents a circle. In this regard, first thing you need to say the degrees of the equation. Okay. The equations should involve variables x and y such that both the variables should have degree 2, and the coefficient of x square and the coefficient of y square in the equation should be same. As well as the variable like x, y should be in the equation. Say for example, here I am giving an equation. Say the standard equation of the circle is x square plus y square equal to r square. Where r is the radius of the circle, and the center of this circle is the origin. And this is the standard equation of the circle. Look, in this equation, how many variables are involved? Two variables. What are they? X and y. And they have the same degree 2. All the variables should have degree 2. And the coefficient of x square and the coefficient of y square in the equation will be same. And then you will identify that equation represents a circle. So this is the equation of the circle. And look, let me draw the diagram. This is the x, y axis. Okay, origin is here. And here, actually is equation represents the circle of this form. This center is at the origin, and the radius is what? R square. Okay. But the number which is in the right hand side, for example, your equation is like this: x square plus y square equal to, for example, 9. In such case, the 9 need to write 3 square. And the base in this case 3. The radius of your circle. Okay. This is about the circle. Dear students, these are the actually basic things we require to discuss of this topic. This is the introduction of this integration. Because of why we are having revision. Till that we are not starting also the main topic. Okay, main topic we'll discuss in the later. Once you know this. All this division at the time only you will able to actually solve the problem of the integration. So because of why we are having the division about the standard equation, the line and the circle and then parabola and then ellipse. Okay. So this is about the equation of the line involving variables x and y such that both the variables have one such type of equation is always represented in straight line, and the equation of second degree of the two variables is involving variables such that both the variables have the mod to such equation circle. In the equation of the circle, the coefficient of x squared and the coefficient of y squared are always equal, and the variable product like x, y is present in the equation. Okay. Next is precedence about the set. Then ellipse. You know, standard equation of the ellipse is this one: x squared y a squared plus a squared y squared by e squared equal to 1. In this case also, denominator of the x squared as well as the denominator of y squared should be right in perfect square. Because in this a square, a represent the length of the semi-measured axis of the ellipse, and the base b represent the length of the minor axis. Okay, and this equation, look, this represents the ellipse is also an equation of second degree involving the two variables x and y such that both the variables x and y possess the same power 2. Okay, so second degree equation. This is second degree equation, and the ellipse is also second degree equation. So how you can actually identify whether it is the circle or is the ellipse? This regarding to check the x and x squared and the coefficient of y squared. In the equation, if it is found that the coefficient of x squared is same as the coefficient of y squared, that equation will represent the circle. And another one, if the coefficient of x squared is found not equal with the coefficient of y squared, that equation will represent the equation of the ellipse. So actually ellipse and the circle are very similar. So because of why I'm telling you about how you can actually know how you can make difference between the circle and the ellipse, and how you can identify very clearly this is the ellipse, or this is the circle like that. This regard to say coefficient of x squared and y squared, whether they are equal or not. If equal, that will represent the circle. If not equal, that will represent the ellipse. Okay. So this is about the ellipse distance. So let me draw diagram about this ellipse. Okay. This ellipse is at the origin, and the ellipse is oval type. Okay. This is called length of the measured axis. How about this part? This is called measured axis. This will be the base of the the length of the semi-measured axis will be this A. Whereas this is called semi-minor axis. The length of the semi-minor axis will be this B. So because of what? Denominator of x and y square needed to be right as a perfect square. Okay. Why? If we write in perfect square, we'll able to know the length of the semi-measured axis and the length of the minor axis. So, I mean, the value of the A and the value of the B will be known by us. Okay. So this is about the ellipse. Once again, there's circle and the ellipse. Equation of circle and the equation of the ellipse are the equation of second degree involving two variables. Okay. Only the difference is that in the equation of the circle, coefficient of x squared and the coefficient of y squared will be same. Whereas in the equation of the ellipse, coefficient of x squared will be equal with the coefficient of y squared. In both variable product like y x present. This is the thing. Another one is parabola. So here, I would like to discuss what that the equations in a parabola. And and
each standard
each standard form.
discuss.
We would like to discuss. Okay.
This actually
This actually sometimes in the last year also in 2024
actually one
parabola question was given by getting the 5 marks. Okay.
and the ellipse
Ellipse also given
actually
circle also
in the last year.
in the last year.
Every year,
CBSE is going one high mark getting from here. But
we cannot
predict that the question to become
will be based on
will be based on the ellipse.
Maybe based on
Maybe based on the ellipse, maybe based on the circle, maybe based on the parabola, maybe based on the line.
Okay,
So
depend on the
depend on the luck.
That's maybe
Sometimes maybe depend on the if you know more about the parabola, you may actually want to give the question based on the parabola, but we cannot predict now
because of
we need to know all the standard equations so that we will be able to solve the question correctly. Okay.
So
Regarding the equation, parabola,
the equation
should involve
two variables.
Okay.
Amongst the
two variables,
x and
x and y,
one of the
one
variables
variable should have degree 1,
and
another one should have degree 2.
So for example, one is variable
y, and another one is variable x.
and amongst the
variables,
one of the
variable
need to have
the degree,
and another
variable have the degree 1.
So this type
of the equation present parabola.
So I would
once again
equation
in which
two variables
are present there.
Amongst
the two variable, one variable should be in degree 2 and another should be in degree 1. Such equations represent parabola. Okay. In this also variable product like x, y should not be present.
So this is
y square equal to 4ax.
Okay. This is the
standard form of the parabola.
Standard form of
The parabola.
And this
parabola is like this.
This is the
parabola passing through the origin
and opening along the
positive direction of the x-axis.
The focus
of this parabola will be on the x-axis
and its
coordinate will be a0.
And this is
the what?
Lectus rectum. This is the
let me name this as the first type parabola.
And the second one is x square
equal to
4ay. See in this
equation also
involving
variables
x and y.
One of the variable is here in this x possesses the degree 2, whereas the y possesses the degree 1. So amongst the two variables present in the equation, if one variable possesses degree 2 and another variable possesses degree 1, such type of the equation will be parabola. So these are the things that I would like to actually have revision. So number one, straight line. Number two, parabola, ellipse, circle. Whenever you must able to recognize. Okay, you must able to recognize what type of the actually curve. By the curve, okay, I already mentioned repeatedly that by the curve, it may be line, it may be circle, it may be ellipse, or it may be parabola. So sometimes questions used to mention the type of the curve. If mentioned, no problem. If not mentioned, must able to identify by actually seeing the equation given here. I already mentioned you that if the equation, the name of the curve is not mentioned, but equation is already given here. By observing the equation, by analyzing the equation, are able to say what type of the curve is given to you. So in this regard, first you need to check the degree of the variable involved there. If both the variables have the degree 1, at that time your equation represents straight line. If both the variables x and y possess same degree 2, at that time your equation may represent circle or ellipse. Okay. So further you need to identify that is it the circle or is it the what? Ellipse. In this regard, you need to check the coefficient of x square and the equality of the coefficient x square and the coefficient y square. If it is found that coefficient of x square is same as coefficient of y square, that will be the circle. And if it is on the other hand, if it is found that the coefficient of x square is not equal to the coefficient of y, that will be the ellipse. Am I right? So about the parabola, I told you that the equation should involve two variables, x and y. Amongst the two variables, one of the variables possesses degree 2 and another will possess degree 1. So yes, I would like to ask one question. Do you know equation of x axis? By what x is represented in Cartesian two-dimensional Cartesian coordinate system? Tell me equation of x axis. Equation of x axis here. Y equal to 0. Y equal to 0. Listen. This is Cartesian coordinate system dimension. So you know that this is the y axis is represented by the equation x equal 0, and x axis is represented by the equation y equal to 0. Sometimes okay. This equation may also needed to us. Okay. To make the boundary. Okay. So here. As we are going to find the area of the region bounded by the curve, first we need to know curve. What about the curve may be given to us? In this regard, we will only discuss. This curve may be given as line, may be given as parabola, may be given as ellipse, may be given as circle. Okay. What type of the ellipse? How you can identify or how you can recognize this type of the curves? I already discussed. Okay. And another one is area. Let me discuss about the area. In this case, by the area, I would like to actually divide cases. Okay. In this case, particularly in this case, area that we are trying to find can be discussed in two ways. Number one is area with respect to x axis. It means that the curve given to you, area of given to you should be defined up to the x axis only. You have to find area with respect to the x axis. Okay. If you wish to find, it is your choice. Suppose you want to find the area with respect to the x axis, it is your wish. Okay. Sometimes it is that okay. You can find the area with respect to the y axis also. Okay. It is depend upon you. What axis you want to find the area. This is to be chosen first. I repeat once again. Whenever this type of the question regarding the application of the integration is given, you are going to find the area of a given curve. So first, what curve is given to you? This is to be known. Second, it is your choice. With what axis you want to find the area? So it is depend upon you. Choose either of the axis. Okay. So by the area you are going to find area with respect to x or area with respect to y. So another thing is that some basic integration. Some basic integration. We need that. Some basic integration. So like integration of x with respect to x. Integration of the x. Do you know integration of the x? What about integration of the x? Integration of the x is x squared by 2 plus c is not required in this case. X squared by 2. And then instead of x is like this. Twice x plus 3. Then what about integration? What about integration? You know that integration of x squared by 2. As you know, integration of x, integration of this can also be done. So this is by linearity property. A property which is called as linearity property. By the linear property, in the integration, linear can be treated as x. Linear should be treated as x. So this is the linear factor. Linear factor is positive degree factor. So to integrate this, the property says that this linear factor should be treated as x. Okay. To be treated as x. If it is x, what about integration? Integration of x is x squared. This is to be assumed x. And you got to integrate by using this formula. Integration of x is x squared. When you say x, you are to write this
is your assumption. Okay. This is assumed as x,
and you are
introducing by using this formula.
It means that this is
treated as x.
But when you write actually,
instead of the x, got to write assumption. Okay.
Integration
of x is equal to
x
squared divided by 2 into coefficient of x.
Here you
want forget that after the integration, the integral should be divided by the coefficient of x. What is the coefficient of x here? 2. So this is the way how the integration can be done.
And this integration
of x
should be
required.
This will be
required. I think the area of the region
bounded by line.
ये लाइन इस्तेमाल होगा
जब भी आपको
find the area under the line.
A line
is given and if it is to find the area under that line. At that time, this integration of x will be needed. Okay.
The second
that I would like to actually have the division about the integration is this integration of root x.
So
integration of root x. Actually, before this, okay.
So what
about the integration of x to the 4 power of integration? This is x to the 4 n plus 1 divided by n plus 1. This is equivalent in physics also.
And then
look,
by using
this you can integrate over integration of root over x. How you can integrate this? First you convert this to power to half. So dx. And then apply this power. Okay. So x to the power half plus 1 divided by half plus 1. So this is the x to the power 3 by 2 divided by 3 by 2. So integration of root x may be needed
when you find
the area under the
parabola. लाइन के लिए
ये
इस्तेमाल हो
जाता है
इंटीग्रेशन ऑफ x
हो सकती है।
इसका नॉलेज
होना चाहिए।
पैराबोला
के लिए नॉलेज होना चाहिए। इंटीग्रेशन ऑफ x ओवर n और रूट x की इंटीग्रेशन जो निकल रहा है इसका जरूरी पढ़ सकते हैं। और नेक्स्ट this is the standard formula or standard that you can say integration of root over of a square minus x square. This is to be actually memorized from your side. This is very important integration. This belongs under the integration of the form root over of quadratic integration of quadratic your syllabus. Okay. So this formula is used to find the integration of root over quadratic, and you need to memorize. You must have to write this formula. Okay. How you can write this formula is first you write x by 2. After the x by 2, need to write this whole integral. Okay. I repeat once again. First you write x by 2. After the x by 2, you write this whole integral. Then plus. After the plus, what you write is a square by 2. After the a square by 2, you write it in sine inverse. And then by a. This is the formula. This formula will be required finding the area under the circle or what? Circle or ellipse. ये formula आपको लगेंगे. This formula is going to be used whenever you are going to find whenever you are finding the area under the circle or area under the ellipse और circle के लिए ये formula जरूरी है. और पैराबोला के लिए ये पावर इंटीग्रेशन ऑफ पावर ये लगेगा on the other hand स्ट्रेट लाइन के लिए ये बेसिक इंटीग्रेशन और लिनियर इंटीग्रेशन ये लगेगा ठीक है so whenever I repeat once again this basic integrals are required these two are required to find the area under the line. And these two are required to find the under the area parabola. And this last integration needed for circle and the ellipse. Okay. So let's start our today's main discussion. Let us actually
start
our
today's
main discussion. Our main discussion is
the
the geometrical meaning of the definite integration A to B fx dx. Actually,
we are
going to find
the
the area of
the
the region
under the
given curve
by
by using the
definite
definite integration.
because of
why? What
does
the
definite
definite integration represent?
What
What
definite
definite integration can do?
This is
to be understood.
Okay.
Okay.
Plus
After this, okay,
we can
study it,
start
start problem solving.
Time
Should not little time is taken because this is what such a topic we need a lot of previous knowledge is okay. But because of why I'm taking a little time is not mine. Okay. Look.
Just what does this
Definite integration says is that
what does
this definite integration says is that
this
definite integration represents
area.
Okay. What type of area? Every area does not be represented by this definite integration.
What type of
The
area
area
of the
of the region is going to be
measured by
this definite integration is required to be understood from our side.
So this
definite integration measures the
area
area
of the
region bounded by the given curve. By the given curve. Suggestions.
This
curve.
I already
mentioned you. I already discussed you.
What
Maybe this curve. I already mentioned you.
This curve
may be line.
This
curve may be
circle.
This curve may be parabola.
This
curve may be ellipse. Okay.
But in general,
instead of mentioning the particular one, I'm mentioning the curve. And each equation I'm mentioning as y equal to fx. Okay.
So if it is
line, you know that the equation should be in the form of x plus y plus equal to 0. Or if it is circle, the equation should be. I already actually had the revised. Okay. Say x square plus y square plus r square with if circle. Okay. If ellipse, this equation should be in the form of x square by a square plus y square is equal to 1 in that way. Okay. So this definite integration measures the area of the region bounded by the curve. Okay. And this area I already mentioned you that what type of the area? The area should be up to bounded. Okay. Up to either x-axis or y-axis. Okay. For the time being, let me mention here only the x-axis. Okay. Sometimes it is your choice. I wanted to mention you up to what we define the area is dependent upon the issue. We say choice. Okay. You can find the area of the region bounded by the curve of the x-axis, or sometimes you can find the area of the region bounded by the y-axis. Okay. Regarding this measure, I will explain this different way. This definition represents area of the region bounded by the given curve represented by the equation for the time being. This curve may be line, may be parabola, may be circle, may be whatever the curve may be. Okay. Let's say curve. Okay. Up to area should be bound by the curve up to x-axis, and between two boundary lines. Between two boundary lines, represented by x equal to a and y equal to x equal to b. You know that. What does x equal to a represent in graphical point of view? X equal to a is represented a straight line parallel to the y-axis and at a distance of a unit from the y-axis. So for example, say x equal to 2. So how you can follow the graph of x equal to 1, 2, after taking the positive, so is the value of x is positive, then we along the positive x-axis,
and the
is here, and this you are to mark a point,
and through
and
this
through
point
this point you are to draw a line parallel to the y-axis. Okay.
So any value
of x,
maybe 5,
maybe 5, maybe 2, maybe 3,
represent
is the line parallel to the y-axis. Okay.
Similarly,
Any value of y,
any value of y
is
is
minus 3,
represent
is
the
the
line
line parallel to the
x-axis.
x-axis.
So
Yes,
yes,
see.
what does
this
definite
integral represent is that
area?
Okay.
What area?
What area?
Area of the reason. What reason? Bounded by given curve. What curve?
The curve may be the line, the curve may be the parabola, the curve may be the circle, the curve may be the ellipse. Okay.
And the
area
of that
curve
should
bound
up to
either x-axis or y-axis.
For the
time being, we are discussing only the reason up to the x-axis. But
in another way,
after some days, sometimes okay, we are going to discuss again with respect to y-axis also. Okay.
And
this
area
should be up to the x-axis and between the two boundary lines. Here, okay.
The boundary
lines may be parallel to the x-axis or parallel to the y-axis. If you are finding the area up to the x-axis, then your boundary lines will be parallel to the y-axis. And the equation will be in this form. The equation will be in this form. A or this. Any number, okay. Sometimes this may be given by the question. If not given by the question, then you have to grab these boundary lines from your side, okay. And you can get, okay. And the working rule is also going to be give you, okay. So I would like to actually have more discussion about this matter, okay.
After that, you
integration, okay. Say, I repeat once again, what definite integration can do? Definite integration can find the area of the reason bounded by a given curve up to the x-axis between the two boundary lines. This thing I would like to explain more explain. Yeah, so as easily understand your side. So just suppose a curve is given. This is the given curve. Okay. So this is the given curve. So for the time being, in this our discussion, this curve is represented by y equal to fx. Okay. This is the given curve. This given curve may be line. This given curve may be circle, or this given curve. I already told you, curve may be given to us. Okay. Line, circle, ellipse, parabola. Okay. Suppose this is the curve. Okay. And what we are going to do, what we are going to find is we are going to find the area under this curve. And this curve should bound up to the x-axis. Area is going to be the curve, and will go up to the exactly x-axis. Okay. In this, okay. What we observe is your reason unbounded, unlimited, and extended like this. Because we have to make it close. Otherwise, area should be defined. To define this area, we need to actually make this region bounded. Close region we need. So to close this region, we need two boundary lines. Say here is one boundary line. So if your boundary line is drawn, between the x-axis means parallel to y-axis, this equation is going to be represented by x equal to. If sometimes it is maybe the y-axis. If it is y-axis, then you know that this equation is x equal to 0. If it is not y-axis, how far this line is from the y-axis. Suppose this line is actually from the y-axis. Then this line equation is x equal to 2. Like that. And another boundary line is also needed to close your reason here. So here, okay. So this is equal to x equal to 3. So now what we observe is a curve. And then area of this curve, area bounded by this curve is going to bind up to x-axis. And to close the reason, we need two boundary lines. So one boundary line is here, and this boundary line is parallel to the x-axis will be here. And how this line from the y-axis, according to that, we will able to find equation. And this boundary line also needs equation. And after that, you have to actually set the reason. Okay.
and the
area
area
of the given region is going to be represented by definite integration. Okay.
and for this
definite integration,
lower
limit
will be
this
lower
boundary line.
lower
boundary line, the line which is
nearer
more nearer to the y-axis.
the
The
equation
equation of the line which is nearer to the
more
nearer to the y-axis should be put in the what?
lower
limit of your definite integration,
and the
boundary line
which is
actually
far
far
away
from the what?
more far
away from the what y-axis should be put in the upper limit.
the
The x equal to upper limit.
and the
And the
integral
integral about the
there is
integral there is this.
about the
About the
integral
integral,
if
if
your
your
area
area is
actually
actually finding
with
with
respect to the
respect to
x-axis, I repeat
once again,
is
if you wish to find
the
the area of the region bounded by the curve
with
with respect to x-axis,
there
here
you need
you need to find the value of y
from
from the equation
that
that representing the curve.
say
Suppose this is line.
now
Now you wish to find
the
the area
bounded
bounded by the line
up to the
x-axis.
In
Okay.
such
In
case,
such case,
you need
you need to find the value of y
from the
from the
equation.
equation that represented the curve.
So
For example, your equation is
line.
line. Okay.
Equation
Equation is your curve is line.
from
From each equation, you have to find out y.
And
And
put the
then put the value of y here.
and the
And
integrate
integrate, and then you will get the required area.
if
The
the curve is
curve is
parabola,
parabola,
then
then also find the value of y from there
and
and put the value here.
and if
And if circle,
you find the
find the value of the what? Y. And the put here. Okay.
if
Ellipse,
you find the
find the value of y from the curve and from the equation representing the curve. Okay.
you find the
Find the value of y.
and the
And then put here,
and
and then integration should be done with respect to x.
integration
Integration should be done with respect to x, y.
because
Because for finding the area
with
with respect to the x,
up to the
up to the x, because of y integration should be done with respect to x. So with respect to x. Okay. What I could actually suggest is dear students,
here
here,
in what
in
way
what way you integral should be considered?
integral
Integral should be considered
from the
from the
equation
equation of the curve.
okay
Okay, find the value of y
from the
from the equation of the curve,
and
then
then
the
the
value of y should be here,
and
and then integration should be done.
after the
After the integration, you will have to find out what area.
so this
So this is the way. Another one is there to this. Suppose
you wish
you wish to find the area
which is
which is y exists.
suppose
Suppose here is the y exists,
and
and
you wish
you
to
wish to find
the
the area with respect to y exists.
then
Then what
shall
then we do?
say
First you throw the
equation
equation of the your what do you want to say curve. Suppose this is your curve. Let me repeat. Suppose sometimes okay, it is your choice.
area
Area can be defined
with
with
respect
respect to the y-axis, or the area can be defined with respect to the x-axis. Is your choice. But one of the axis should be actually choose from our side. Suppose we choose y-axis to find the area of this curve. Okay.
the
The
equation
equation of this curve
will be
given by the equation.
so this
And this curve may be
line
maybe
parabola,
parabola,
maybe
circle, maybe ellipse. Okay.
right
If you wish to find,
what I
what I suggested is,
if you
if you wish to find
the
the
area
area
with
with respect to the y-axis,
there
there
you
you
are
are to find
the
the
value
value of the
x
x
in terms
in
of
terms
the
of
y
y
from the
from
equation
the equation.
and that
And the
value
value
of
of
x
x
should be
should be used
used
in the definite integration. Okay.
on the
On the other hand, if you wish to find
the
the area of the curve with respect to the x-axis,
then
then you can find the value of y
from
from the equation of the curve.
and
And that value of y should be used in the integral of the definite integration that
is
is going to represent the area. Okay.
any question
Go on.
क्वालिटी को मास्क ঠিক আছে
It's okay now.
Rajesh sir, you're back.
Bit down because of there was some disturbance. Okay, sorry for that. Suppose
this is the curve,
and
and
we used to find
the
area
area
with respect to y axis.
In this
case,
what
we need to do is
yes
we
used to
find the area with respect to y axis. I would like to suggest that
from
the equation of the curve,
we need
we need to find the value of x. If
we
we used to find the area with respect to y axis, then we are required to find the value of x. With respect to y axis, within the value of x. Okay. With respect to x axis, within the value of y. Okay. So
if we
if we find the area of the curve
up to the y
axis,
then from the equation
of the curve, equation may be line,
maybe
parabola, maybe circle, or maybe ellipse. From that equation representing the curve,
you find
out the value of x. If you wish to find with respect to y axis, okay.
and then
as you see, this is the diagram. Maybe actually maybe this diagram. Okay. And for the time being, is observed that our we have to find the area this comes up to the y axis, but the area is not closed. The reason is not closed.
Yes, the reason
is not closed. The area will be undefined. So to make defined, we need to close this area. To close this area, and sometimes question may be mentioned that from this to this you are to find the area. If not mentioned, the whole area should be taken. If mentioned area should be actually taken. Suppose it is mentioned that from suppose y equal to suppose 3 to y equal to say 7 like this. Okay. So here these two are called boundary line. Okay. Sometimes these boundary lines are given by the question. If not given by the question, we are to get from our side by knowing the question. By understanding the question, we are to create this boundary line with the help of the question. By understanding the question. Sometimes this given by the question. If only given by the question, it is good. Okay. If not given, we have to be actually our side, so it is able to know the reason for which the area is going to be determined.
So it's now
our actually what we observe is that the area is small, and the area for which the area is going to be reason for which the area is going to be determined. Is that actually it means that for them you are going to draw the or you can say diagram. Diagram is needed. Okay. In mathematics, diagram is most of the time required. The diagram based solution is also the best solution. Okay. And most of the time, whether you to write the symbol in a notation, okay, instead writing what Thomas Landy, okay. So this area you can represent by the definite integration. Limit boundary line is 3 to 7. So here 3 is 3, and here 7. And this integral as I already told you, integral should be taken from the equation of the curve. And here the value of x should be taken. Value of x is what we want to find the area up to the y axis. Integral with the value of x, which is obtained from the equation of the curve. Your equation of the curve is line. From there you obtain the value of x, and that value of x should be here. If circle circle can be named by the C, and then from that equation of the circle find the value of x here. And here integration should be done with respect to what? As we are going to find out the area up to the y axis, integration should be done with respect to y axis. Okay. So this is the actually theoretical part that you need to understand. Okay, there should so as to solve this type of equation. So let us see one example before solving the question. Okay, let us actually back to the division part very quickly. Say number one. What type of the curve is given to you to find the area? Okay, maybe line, maybe parabola, maybe circle, maybe ellipse, as per our syllabus. And what type of equation represents straight line? First degree equation of two variables.
And
what equation between the present circle? Second degree equation of two variables such that coefficient of x squared is same as coefficient of y squared.
And
about the ellipse,
it is also
second degree two variables such that x coefficient of x squared is not same as coefficient of y squared.
And the
fourth one is parabola equation
involving
two variables. There
one of
the variable
possesses
the degree 2
and
another variable possesses the degree 1.
and
And a third equation represented parabola.
And
the
second thing
that we need to know is about the basic integration.
For the line,
what type of the integration may be needed? Say integration of the x linearity property that I already mentioned,
and
for the parabola what may be needed? Integration of x to the power n, integration of x like that. Okay, that may be needed.
and
For the one circle and the ellipse, integration over of a square minus x square will be required. Okay, so these are all things needed to understand to solve this application of integration question. Okay. Some students used to say actually before COVID, okay, area between the two curves was there. Actually, this time, previous year also, CBSE already actually randomized the syllabus, and simple curves is needed for our for this actually session. Okay. Last year also simple question was there. So let us see one last year question. Okay. Here is the question. So here is the question that is type.
It's okay now?
Okay now?
It's okay.
It's okay.
Is
Is it visible?
Visible now?
Visible now?
Okay.
Okay.
Look,
Dear students,
what
this question was given in 2024. 700 also already mentioned here. 65 public 4 public 1.
Okay,
let us actually analyze this question. Okay. Say using integration, we are going to use the integration.
Find the
area bounded by this is
the name
of the curve is already mentioned by the question.
It's good.
It's good. Okay.
Sometimes
the name may not be actually mentioned by the question.
At
that time, what you do?
You have to
check these degrees of the variables involved in the equation, as I already mentioned. Does both the degree 1? If so, line. If both the degrees, if both the variables have the degree 2, then it will be either ellipse or parabola. Ellipse or circle. And for the circle, coefficient of x square and the coefficient of y square are needed to be same. For the ellipse, coefficient of x square and the coefficient of y square are generally not equal. Okay. And about the parabola, one of the variables should have degree 2 and another variable should have degree 1. So first of all, let us identify the curve. What is the curve here? What is the curve given here? Ellipse. Okay, this is the ellipse. Okay. So you are going to find the area of the ellipse. Okay. And the already mentioned that areas should be defined with respect to x-axis. Sometimes it may not be mentioned. Okay, for this question, it is already mentioned that areas should be defined with respect to the x-axis. After the x-axis, what we find. Okay, and sometimes it may not be mentioned that areas should be defined either with respect to x-axis or either with respect to y-axis. In such case, it is your wish. Okay, if you want, it is your choice. You can find. If you choose the x-axis, then it is also okay. If you choose the y-axis, it is also okay. It is up to you. Okay, but for this, it is already actually given by the question that area should be with respect to the x-axis. And above the boundary line. In this okay, two boundary line. Okay, so close your reason. Okay. These two boundary line also already given by the question here. One is x equal to -2 and another one is x equal to 2. Boundary lines already given in this case. Sometimes these boundary lines are also not given. Okay. For this question, boundary lines are given means that the question is little bit easier. Okay. So now let us see. Let us see. Let us solve this question. Okay.
the way
actually
I would like
I would like to give you
best
best solution actually.
the
The solution given by all the students, but amongst the solution, actually CBC used to select the best solution. Actually, I would actually from my side, let me try. This will be the best solution, okay? But it may not be the best solution also. See. Say
solution.
First of all,
I would like
to actually identify what type of the clock is represented by this equation.
So
to identify. And suppose your ellipse is not mentioned. At that time you need to identify what clock is represented by this. So in this regard, first you need to check the degrees of the variables involved in the equation. Here two variables x and y have degree 2. Both the variables have degree 2 in second degree in both the variables x and y. So such equation represents ellipse or circle. The product ellipse coefficient of x squared should be the same as coefficient of y squared. Here it is seen that coefficient of x squared is 9 and the coefficient of y squared is 25. Are they same? No. So this equation will represent ellipse. Okay. So this is ellipse. So given right here, you start with the given curve. The given curve is what? Ellipse. Better you name curve by E. Okay, ellipse. Okay. And what is the equation? 9x squared plus 25 y squared equal to 225. I repeat once again, dear students, if this ellipse is a circle, you may represent the equation by C. If it is parabola, you may represent you may give the name of the curve. Okay. Say like ellipse for ellipse E, for circle C, for parabola P, like that. Okay. For line L. And as it is only mentioned, the area to be found with respect to x-axis. Yes, we used to find the area with respect to the x-axis or area with respect to the y-axis. Then for that, we need to find the value of x and y from this equation. But here we need to find that this actually already mentioned by the question that your area should be defined with respect to x-axis. Because of y, from this equation, we will need the value of the y. If it is defined with respect to y-axis, from the equation, you will need the value of what? X. Okay. If it is to find So suppose first I would like to actually suggest you to write the equation of the given curve, and then maybe as per the type of the curve, if ellipse E, if circle C, if line L, if parabola P, like that. Okay. And after that, with what axis you want to find the area? You have to choose yourself. Okay. For this question, you cannot choose because all the equation mentioned that area should be with respect to the axis. If the area is to find with respect to x-axis, there you need to find the value of y. So let us find the value of y from this equation. Say 25 y squared. To find the value of y involving terms should be in the left hand side, and bring this to this side. Say 225 minus 9x squared. Okay. First, better to learn. Just a minute. First, better to put the equation in the standard form. The standard form of the ellipse is what? Standard form of the ellipse is x squared by a squared plus y squared by b squared equal to 1. Okay. So to put this equation, we came to know that this is ellipse. Okay, because the coefficient of x squared is not same as the coefficient of y squared. So after knowing the type of the equation, type of the curve represented by the equation, you should bring the equation into the standard form. Okay. So as it is ellipse, this is to be bring in this standard form. Okay. For this, your right hand side should make 1 first, dividing so as to make right hand side 1, dividing on both sides by 2 to 5. So here x squared divided by what will come here? Is it to that 25? Right. So divide by that. Dividing all the terms by 2 to 5 so as to become right hand side 1. to become in the standard form, okay, 9x squared divided by 225 plus 25y squared divided by 225 and 225 divided by 225. Then what is this? X squared by 25 plus y squared divided by what is this? 9 equal to 225 by 225 is 1. Now your equation is actually reduced into the standard form, and you can compare this equation with this equation. If you compare, a square is what? A square is 25. From this you can say that the value of a is 5, and the b square is what? 9. Okay. From this you can say that the value of b is what? 3. It means that semi-major axis is 5 and a semi-minor axis is what? 3. And as you are to find the area with respect to after this, okay, another one, x square by 25, better to write as perfect square 5 square, y square is the perfect 3 square equal to minus x squared. So y will be required, okay, in our further actually steps, okay. So just let's say what I suggested. First, you need to know the type of the what type of curve is given to you. For this, you need to check the degrees of the variables, as I suggested repeatedly to you. And after that, if ellipse, you name the graph by E, if circle by C, if parabola by L. Okay. After that, you do find the value of you do express your given equation in the standard form, if not standard. After standard, okay. After becoming in the standard form, for the circle, you need to find the radius. For the ellipse, you need to find the length of the semi-major axis and the length of the semi-minor axis. Okay. This is what ellipse we need: length of the semi-major axis and the length of the semi-minor axis. Major axis means length of the semi-major major axis means the value of the A. The length of the semi-minor axis means the value of the B. This will be required in drawing the graph. Okay. Graph means diagram. Diagram is needed to identify the reason for which area is going to be determined. So, dear students, say up to this, I hope you are understanding me. So, after this, okay, we will come in the diagram. See, to draw the diagram can be drawn in your answer book, okay. No need that it is to be drawn in the graph paper, okay. But your diagram should be look like very neat and clean and very actually very actually neat and clean and the very look should be very nice, okay. This is the what y axis, x axis, origin is here. Okay, and the ellipse is already drawn here. It is the continuous curve. Okay, this is the ellipse, suppose, and this is your curve. Okay, this is the curve. You can name what is your curve? E, ellipse. Okay, ellipse. This is the ellipse. Okay, this is your ellipse. Okay, and you can mark here. What is the your? Just a minute. Ellipse can be drawn by using what to say ellipse also. So this is y axis and this is x axis. Origin. Actually, what was the value of A? A is the length of the semi-major axis. What is the value of A? A was 5 now. A was 5. And what about the B? B was 3. Based on this length of the semi-major axis and the length of the semi-minor axis, we need to draw the diagram. Say here you mark 5. 1, 2. So 1, 2, 3, 4, 5. And this side also you can draw 1, 2, 3, 4, 5. And here in the actually, what does it mean that your length of the semi-major axis is going to be 5, and the total length of the major axis is 10, and the axis is 3. 1, 2, 3. Here also 1, 2, 3, and then you can draw the ellipse now. This is your ellipse. This is way to draw the ellipse, okay. And you can mark here the name of the ellipse. Your name of the ellipse is E. Okay. And you are going to find the area with respect to x-axis, okay. Area with respect to. Look, it is already mentioned by the question that look, at present our curve is this, okay. This is our curve. And it is also mentioned that area should be up to x-axis. Okay, area should be up to the x-axis, and between the two boundary lines. Boundary lines are also already mentioned by the question. What was the boundary lines? One is x equal to -2, and another is x equal to 2. So where is the x minus x equal to -2? X equal to -2 is here. 1, 2. At this -2, you need to draw a boundary line here. X equal to -2. Okay. Another one is x equal to 2. X equal to 1, 2. You need to draw another boundary line here. So you have to find area from here to here. This is your curve, and your curve is bound the region up to x-axis, and between these two boundaries, we are going to find the area of this region. Okay. Blur down. Network is totally down. Okay. Net string is little bit down. Okay. So boundary lines are already given by the question that from -2 to 2. Okay, -2 to -2 is here, and the 2. And I repeat once again, this is the curve. Your curve is E. Your curve is E. E is here, is ellipse. Okay, and this will be close. This will be bound up to x-axis, and between these two boundary lines. It means that the question here. Okay. This one, and this type of area can be represented by the definite integral. Now, this area is going to be actually measured by the integration. So x equal to 2 minus 2 to 2. Okay. In this minus 2 to 2, your ellipse is going to bound the region up to the x-axis. Okay. This is to be found by a definite integration. Okay. In what way? This region is this area of this region is going to be represented by the definite integration by the same. You need to see the diagram. So now required area. This is the area. The shaded region in the diagram is our required area. The required area will be what? Going to be represented by unit integration. This is to be from -2 to 2. So -2 to 2. Okay. And as I already mentioned, if you are going to find the area with respect to x-axis, the value of the y from the equation of the ellipse, I already put in the box. Okay. That value of y should be right here. And you say EY. EY means from the equation of the ellipse, we found the value of y, and that value of y should be put here. And what does this say is that area from, and the area is closed, area is bounded by this ellipse up to x-axis. So here, as the area is hiding up to the x-axis, integration should be done with respect to x. And then say -2 to EY. Net. This is down, right? Little down. This thing is little down. Say EY, the value of y already actually obtained by us. That value of y will be put here. What was the value of y? The value of y already actually found in advance is this one: 3 by 5 root over 5 square minus x squared. That will be put here. 3 by 5 root over of 5 square minus x squared. After this, okay, integration should be done by using the that formula I already mentioned. Okay, for the circle and ellipse, one formula I already suggested. That formula is needed here. Okay, so first of all, this is multiple constant. Multiple constant can take out from the symbol of integration. You take out it, and then integration 2 to 5 over of 5 square minus x square. So for this, by that formula, I already gave you root over of a square minus x square. That formula should be implemented here. Before that, you use 1/3 bracket, okay, or second bracket. You can use. After that, integration of this will be right by using that formula. Already actually gave you root over of a square minus x square. Root over of a square minus x square integration is x by 2. After the x by 2, you need to write this whole integral here, as I suggested. Now, once the integration is over, this part over the integration. Once the integration is over, you can put the limit -2 to 2. Okay. And after this, you write plus second term of that result. Okay. A square by 2. What is a in this case? This is actually comparing with our standard result. Root over of a square minus x square. A by the a, it is 5. Okay. So what is actually what we supposed to write here a square by 2 means 5 square by 2. Okay, a square by 2 by the a in this case 5, a square minus x square. So its integration. The second term is a square by 2 and then sine inverse of x by a 5. And once the integration is over, you can put the limit here. Limit should be taken only to the what variable function. Okay, minus 2 to 2. Okay, and then so 3 by 5. And after this limit, put a limit. It is okay. You will get the mark. Suppose you are unable to actually complete, unable to do all the complete solution. Suppose you stop here, then 90% of the mark may be awarded to you. The